Picture this. You're standing right next to a massive, multi-ton piece of heavy railway machinery, the Plasser India BA09-3X. And you aren't just looking at it today, you're actually getting in the driver's seat. Welcome to this explainer. We're going to take a virtual shift operating this absolute beast of a machine. Now, operating railway maintenance tech of this scale, it is definitely not like turning the key in your car. It's a highly precise, rigorous discipline governed by strict protocols, physics, and literally immense mechanical power. So by the end of our time together, you're going to understand exactly what it takes to bring this giant to life, move it safely down the tracks, and finally put it to rest. Okay, let's dive right into this. We've got a really clear step-by-step roadmap for our shift today. We'll start with pre-start preparations, move into firing up the engine, run through our pre-travel safety checks, cover some traveling and driving tips, look at how to change cabins and reverse, and then we'll wrap it all up with shutting down and securing the machine. All right, so section 1 on our agenda, pre-start preparations, before you turn the key. So, you've just walked up to the cold machine for your shift. The absolute golden rule of railway operations is that preparation is the foundation of all safety. You just cannot cut corners here. Before you even think about hitting the ignition, you have to verify this pretty dense checklist of essential liquids and lubricants. We're talking about checking the engine, fuel and oil, the water cooler, the compressors, and the pneumatic oiler. And honestly, it doesn't stop there. You've got to inspect the driving, axle, and pump distribution gearboxes, check the hydraulic oil tank, make sure there's grease in the central lubrication unit, and of course, verify the batteries. Skipping any of these checks isn't just, a minor oversight. In a machine this complex, a dry gearbox or a low hydraulic tank can lead to a catastrophic, wildly expensive mechanical failure right out there on the tracks. Now, what's really striking on this slide is this massive number, 100 bar. During your pre-start walk-around, you have to check the accumulators for the system pressures and the tamping pressure system. Both of these need to be sitting at approximately 100 bar. To put that into perspective for a second, your standard car tire is usually inflated to about 2.2 bar. So we're dealing with immense, highly pressurized systems here. You've also got to check the squeezing cylinder at 35 bar and the satellite support accumulators at an incredible 120 bar. These numbers really establish the real-world stakes. I mean, the physical forces contained within this machine before it even moves are just staggering. While you're doing all this, you're also verifying switch positions. Parking brakes removed, main battery on, circuit breaker on. If everything is right, a green LED for the program run lights up. But what if it shows red? A red LED means a program failure, which interrupts all functions. This brings us to a really fascinating emergency protocol. As the manual specifically notes, watchdog bridging can be carried out by means of a switch, under observance of all the prescribed safety measures. Basically, this is a manual override. If the computer throws a fit, you have the authority to bridge this watchdog circuit to regain control. But it requires incredibly strict adherence to safety protocols, and it's accompanied by a flashing warning LED. It's just a great reminder that the human operator always has the final, critical say. Moving right along to section 2, firing up the engine, the starting sequence. Okay, the fluids are checked, the pressures are good, and the switches are set. Let's wake this machine up. But first, to make sure you're fully utilizing the battery, every other power-consuming unit must be off. Here is the exact sequence to bring the engine to life. Step 1, insert the key. The charge indicator lights up, and the ammeter will actually display discharge. Step 2, check the voltmeter to ensure your battery voltage is healthy. Step 3, activate the electrical engine acceleration for whichever cabin you're using. And step 4, turn the starting switch clockwise until the engine runs. Now, a quick heads up. If the engine doesn't start, the manual is crystal clear. Do not persist. You absolutely must discontinue the attempt and wait for a full minute before trying again. Otherwise, you're going to burn out the starter motor. Environmental conditions can totally change how you handle this beast. Take a look at this comparison. Under normal conditions, you warm it up and just engage the gear. But if you're working a winter shift and the temperature drops below 5 degrees Celsius, the whole protocol changes. In cold weather, the gear must be explicitly decoupled. See, the hydraulic fluids and oils get really thick and sluggish in the cold, so decoupling the gear removes all that physical resistance. This greatly facilitates the starting process and saves the engine from a ton of unnecessary strain. So she fires up. Awesome. But you don't just throw it in gear and hit the throttle. The manual strictly mandates a warm-up period at a moderate RPM for about 5 minutes, completely without any load. Think of this just like an athlete stretching before a heavy workout. The fluids need time to circulate, temperatures need to equalize, and all those heavy mechanical components actually need to expand to their proper operating tolerances. All right, the engine is purring nicely. That brings us to Section 3, pre-travel safety checks, securing the machine. We can't actually move yet. Moving a machine of this magnitude requires a whole new checklist just to verify the travel systems. Before the BA093X moves a single inch, these metrics must be locked in. You need your pneumatic pressure at roughly 7 bar and your brake pressure at roughly 3.8 bar when you actuate the lever. If there's a pressure loss here, you don't move. You stop everything and find the leak. You also have to verify that emergency brake valves are closed, test your electrical and pneumatic horns, and check all the lighting. And this is absolutely crucial. All working units, like the heavy tamping units and satellites, must be properly locked and secured with safety ropes and locking chains. Finally, ensure the ZF gear is engaged, but leave the driving gear in neutral. We are cleared for travel. Section 4, traveling and driving tips, hitting the tracks. Okay, so the machine is verified for travel. You pre-select your direction, switch on the lighting, and get moving. But driving a multi-ton railway machine is an art that requires constant vigilance. Mastering these best practices in motion is just essential. First, keep your eyes glued to those monitoring instruments. Always adapt your speed, meaning you slow down on track points or if you hit badly positioned tracks. Now here is a golden rule. You must never travel on gradients without an engaged gear, and you must never, ever let the engine drop below 1000 RPM. Coasting is incredibly dangerous. You literally need the engine RPM high enough to pump fluids and cool the gear. If you're doing mountain or valley travel, you switch down to lower gears early. And remember, hitting the full brakes, that is reserved strictly for emergencies. Next up is Section 5, changing cabins and reversing, shifting directions. So this machine is designed to work efficiently, which very often means you need to move it in the opposite direction. As a general rule, you should use the cabin that's actually facing the direction of travel. But swapping cabins or reversing isn't just about flicking a switch. Think about the physics at play here. Thousands of pounds of steel sitting on smooth iron rails. So let me ask you, what do you think is the absolute non-negotiable prerequisite before you can shift this machine into reverse or physically change operator cabins? Well, if you guess zero momentum, you hit the nail on the head. The machine must be completely stationary. You pull the brakes fully in, getting that maximum braking cylinder pressure, but you don't actually lock the lever into place. Next, the gear switch goes to the neutral position. Then, you turn off the key-operated switch of the gear control and physically pull the key out of the console. And right before you stand up and leave that cabin, you lower the engine down to idling RPM. This extremely strict protocol ensures the machine absolutely cannot accidentally engage or roll while the operator is walking between the cabins. Finally, we've reached Section 6, shutting down and securing, ending the shift. The track work is done and it's time to pack it in. But parking a massive railway maintenance vehicle is an intensive procedure. It's designed to protect both the equipment and the rail network itself. And this really illustrates the difference in scope depending on how long you're actually walking away for. A normal engine stop, say for a short break, is fairly straightforward. You let it idle for a few minutes to cool down, push the engine stopping button, and pull the parking brakes. Done. But if the machine has to be stopped for a longer period of time, you have to enter a totally different, highly exhaustive sequence. A long-term shutdown is really about bleeding the energy out of the machine and physically anchoring it to the environment. You apply the parking brakes and pull every single key: the ignition, the power shift gearbox, the main battery switch. Gone. Then, you actually have to physically drain the compressed air containers and the drip cup, making sure to close the drain valve once all the water is out. Then comes the physical lockdown, shutting windows, locking cabin doors, and securing those heavy engine compartment sidewalls. Finally, you have to interface with the rail network itself. You set up stop signals or safety flags and physically attach heavy brake shoes to the wheels and rails. Once that's done, the machine is completely immobilized. And there we have it. We've gone from a cold, silent machine to checking high-pressure accumulators, bridging digital watchdogs, managing track gradients, and completely immobilizing a mechanical giant. It really is a masterclass in safety and precision. So as we wrap up this explainer, I want to leave you with this question to think about. After mastering this complex web of pressures, protocols, and overrides, how does it change your perspective on the immense responsibility resting on the shoulders of heavy railway operators? Every smooth, fast train ride you take is built on the back of this exact kind of rigorous discipline. Thank you so much for joining me on this virtual shift, and keep learning.